Okay, so the next thing we're going to do is apply the idea of standardizing this normal distribution in order to help us solve some more complex questions. And generally, this is when you don't know either the mean or the standard deviation of a distribution. You need to find them. So in the previous example and the video and the previous exercise, you might have been thinking, well, my calculator does all this for me. Why do I need to do this standardization process? Well, here now is why you need to do it. So let's jump straight in with some examples. In example 8, we are told that our random variable x is normally distributed with an unknown mean, mu, but a variance of 9 or a standard deviation of 3. And the only thing we're told to help us find out this unknown mean is that the probability that x is greater than 20 is 0.2. So let's go in and see what we can figure out now. First thing we need to do is to take this statement here, we'll copy it out again, and then we'll standardise it. So that means the probability that z is greater than, and remember we're going to use this code, x, so that's your x value of 20, minus the mean, which we don't know in this case, divided by the standard deviation, which we do know is 3. Be careful not to use 3 squared there, just 3. We know that the probability that z is greater than that is 0.20. Now, so your first thing you're going to do is standardise. The next thing you're going to do is sketch this standard normal distribution and mark on what we're dealing with. So step 2, let's do our sketch. We know that the standard normal distribution has a mean of 0 and a standard deviation of 1. And what we know is that the probability that z is bigger than some value, but then 20 minus this unknown original mean over 3 is 0.2. So where is this value along the z-axis here? Well, if the probability we're bigger than it is 0.2, which is less than a half, it must be this side of 0. So somewhere around about here, because we know that the whole probability greater than 0 there is 0.5. So 0.2, an area of 0.2 looks something like that. And what we're saying is that this value here is 20 minus mu over 3. So at that stage, we're going to come to our calculator because we want to find out what this value actually is. Don't forget on your calculator for inverse normal, it always works out the area to the left of a value, or it works based on that. So we need to work using 0.80 here. So we have got our inverse normal there. The area is 0.80, keeping 1 and 0 because we're on z now, we're on the standard normal distribution. And we have this value coming out as 0.8416. That's our z value. So let's come back up here to the question. That means we know this. We know the probability that z is greater than 0.8416 is 0.20. So how do we use that? Well, basically, we're going to equate 20 minus mu over 3 with 0.8416 and work out what mu is from there. So let's take 0.8416 and multiply it by 3 so that we get 20 minus mu is 2.5248. So that gives us that mu would be 20 minus that number, and it's 17.4752. So let's go 17.5 to 3 significant figures. And we've found the mean of the original distribution. So if I come up here, what we've worked out is that this value here is roughly 17.5. Now, let's just go back to our list of what we did here. First of all, we standardised, so we turned x into z using the coding. Secondly, we sketched. Thirdly, we used the calculator to find the Z value in question. And fourthly, we undid our original calculation. We work out the unknown, and that was by equating the value of Z with the calculation for Z. So those are that's a kind of a general format for every single one of these questions, and you'll always follow that process. Like I said in the previous video, don't try and do it without sketching the curve, because that's just silly. Here we go. Let's go on to example 9. Now in this one, we are told some context. So we're told that a machine makes some metal sheets, and the width of the metal sheets is modelled using the variable x. It's modelled as a normal distribution with a mean of 50 but an unknown standard deviation. What we do know, however, is the probability that a diameter will be less than 46 is 0.2119. And we've got to find the value of sigma. So I'm going to pick up my last sheet, and I'm just going to come back to that list, because these are our points of what to do each time. So the first thing we're going to do is we are going to standardise this statement here. So that means we take the probability statement, we turn x to z, and we do apply our transformation, which don't forget was z is x minus the mean divided by the standard deviation. So our x value is 46 minus the mean of 50 divided by the unknown sigma, and that's 0.2119. So let's just tidy this up a little bit. 46 minus 50 is of course minus 4. So we have probability that z is less than minus 4 over sigma is 0.2119. So we've done our standardisation and we've tidied it up. Now let's do our sketch. It's a standard normal distribution, so it goes through 0 as the mean. It's only a sketch, so don't worry, it doesn't have to be a work of art. But the probability, we're dealing with a negative net value here. The probability we're less than it is 0.2119. So to mark it on, it's going to be somewhere like that. And we know that that area there is 0.2119. And we will call this value minus 4 over sigma. That's our z value there. So we've done our sketch. Now we're going to use our calculator to actually find out this z value. So we go to the distribution and inverse normal. Our area is 0.2119, keeping mu and sigma as 0 and 1. And that tells me that this z value here is actually minus 0.7998 to 4 decimal places. So now what we're going to do is we're going to take my minus 4 over sigma and this number, we're going to equate them to work out our unknown. So we'll write out the equation we're solving. Minus 4 over sigma equals minus 0.7998. So we need to do minus 4 divided by, go back, there we go, minus 0.7998 to give me a sigma value of 5.00 to 2 decimal places. 3 significant figures. Now, part B of this question asks me to find the 90th percentile of our variable x. Now, 90th percentile, let's call the value of the 90th percentile lowercase x, shall we? Because we tend to use lowercase letters for individual values along the horizontal axis, and uppercase letters represent the whole distribution. So we'll call the 90th percentile x, and what that means is the probability that our anything in our distribution is less than this particular lowercase value x is 0.9. Well, that's 90%. So at that stage, let's go to our cumulative normal, our inverse normal distribution, because what we're dealing with is on the original curve. Let's sketch the original curve, not the standardised one now, where the mean was 50. We've now worked out the standard deviation. Let's write it up here, shall we? We've now worked out that the standard deviation was 5.00, so we have 5.00 squared there for the variance. So on this curve, the chance, we're trying to find this value, lowercase x here, where the chance of being less than it is 90%. So we're going to go to our inverse normal, because we're trying to find a value on the x-axis. The area is 0.9. This time I haven't got the standard curve, I'm going back to the original curve here. So our mu is, our sigma is 5.00 and our mu is 50. And that tells me x is 56.4. So that's that value there. And that's the 90th percentile. So for our last example, example 10, I'm going to move these pointers out of the way now, but we're going to stick to them. We have to find for a distribution, which we're not given any context for, but we know it's normally distributed. We have to find the mean and the standard deviation. We don't know either of them. What we do know, however, is that the chance of being greater than 35 is this, and the chance of being less than 15 is this. So what I'm going to do first of all, point 1 on my list was to standardise. So I'm going to standardise both statements now, starting with this one. So the probability that z is greater than x minus mu over sigma is 0.025. Now let's standardise this one. That gives me the probability that z is less than 15 minus mu over sigma is 0.1469. So what's going on here then? Let's do our sketch next, because that always comes next. There's my standard normal distribution, and because it's the standard one, we know we're going through 0. So we have z on this axis here. Now let's work out where both of these points are located. This one, probability of being greater than it is 0.025, so it's a pretty small chance. So that's up here, isn't it? And I want to find that value there, because that's what I'm going to equate to this. But then, coming over here, the probability that we are less than this value is 0.1469, so it's a slightly bigger probability than that one, but we're less than, so something like that perhaps. 0.1469 goes there. I want to find that value as well, and that's this one. So I could write on here the calculations that give these values. So this one is 15 minus mu over sigma, and this one was 35 minus mu over sigma. So let's go to our inverse normal on here and start to work with these. I'm going to keep it with the standard normal distribution, so I'm leaving the 1 and 0. But first, we always need the area to the left, so let's deal with this side first, because that's already given me the area to the left. So I'm going to put in there 0.1469. So we have got then that number is coming out as minus 1.0498. So I'm just going to write the equation down over here and think about it in a moment. So I have got, from this side, 15 minus mu over sigma is minus 1.0498. Now let's do the peachy coloured one. But for the peachy coloured one, I need to remember that I need to know the area to the left of that point in order to use the function on the calculator. So I need to do 1 minus 0.025. So let's make a little note of it that we're actually dealing with that area there. 1 minus 0.025 is 0.975. So in my calculator, that's the area I'm going to put in. And that tells me that this number here is 1.95996 and so on. So let's write down the equation from that one on this side. We have got this 35 minus mu over sigma is 1.95996. I don't quite know to what degree of accuracy we've got to do this, so I'm just going to keep them both pretty accurate like that for now, and it will all come out in the end quite nicely, I'm sure. So we have got two equations. Let's, on this one, do a bit of tidying up. So I'm going to multiply a sigma to by both sides. So 15 minus mu equals minus 1.0498 sigma. And I'm going to call this equation 1. And then on this side, do the same thing. Multiply both sides by sigma 1.95996 sigma. And I'm going to call this equation 2. So we have got two equations, two unknowns, mu and sigma in both, so we're going to solve them simultaneously. Now, of course, there are lots of ways to solve simultaneous equations. What I notice with both of them is that we have a minus mu. So if I subtract one from the other, I will eliminate mu. So I'm going to do equation 2 subtract equation 1. So I'll have 35 minus 15, which is 20, minus mu, subtract minus mu, which is nothing. And then I have got, let's go back to normal calculations, 1.95996 sigma, subtract minus 1.0498 sigma. So how much sigma have I got? That's 3.00976 sigma there. So sigma is 20 divided by that. Sigma is 6.645 to, let's go, well, let's keep it like that for 6.65. Let's go 6.65 and we'll put it to 3 significant figures there. There we go. We'll go straight for that. Now, when I've worked out sigma, then to find out mu, I need to substitute sigma back into one of these two equations. So let's just go for equation 2. So now we will sub sigma is 6.65. I'm going to be a little more detailed actually. I'll keep it with the 645 for now, into equation 2. So that gives me 35 minus mu equals 1.95996 times by my value of sigma. So to find mu, I'm going to take my value of sigma that I've left on the calculator, I'm going to multiply it by 1.95996, and then I'm going to subtract that from 35 to get 21.976. Now ultimately I need to leave all my answers to 3 significant figures. So finally I'm going to write them both down. Mu is 21 what did I say, 3 significant figures? Yep, so 22.0 to 3SF, and sigma is going to be 6.65 to 3SF. And there we go. You now know everything you need to know in order to do exercise 3E.